Hi guys, second week of Algebra Boost Camp, yahoo yahoo. So background noises this time, my washing machine is going and there's like the apartment above me I guess is taking a shower, so I hear a drip drip from the water, so just ignore those if you hear those. Okay, so today we are doing equations with the variables on both sides. So that's when you have two sides of your equation, the two expressions, and they both have a variable. But this time it's going to involve decimals and fractions. So instead of just moving on, I wanted to focus on this on Monday, just to spend some time with it, just because equations and being able to solve them is extremely critical for algebra. Like, that is the foundation of algebra, equations. So we're going to do 4 examples, 2 with decimals and 2 with fractions. So the first one, 0.5s plus 1 equals 7 plus 4.5s. Okay? So I know now if you were in Mr. Hill's class, you guys did not draw the line to separate the two expressions, and that's perfectly fine. It does not matter. It's just a visual thing. My kiddos, we box up the variables and we draw our line. Okay, so now what you have to do is, just like if these were whole numbers, we have to get like terms combined. You combine like terms. We got to get these whole numbers, okay, the constants, on one side of the equal sign. It does not matter if you take this 1 and move it over there, or if you take the 7 and move it over here. And then we have to get the coefficient with the variables together also. Okay, usually you like to get the constant, the numbers on one side, and the variable with the coefficient on the other, just to minimize the number of steps you have to do. So I'm going to do the constants first. I'm going to subtract 1 from both sides so that I can keep my numbers positive. 1 minus 1, it cancels out. 7 minus 1 is 6. Okay, so that leaves me with the 0.5s on this side equals 6 plus 4.5s. All right, but now we got to combine the variables. So yes, you could subtract 0.5s, but then eventually you're going to have to move it back over here. So I'm just going to subtract 4.5s from both sides. 4.5s minus 4.5s cancels out. 0.5s minus 4.5s. So you can use a calculator, but we really got to work on number sense. So 0.5 minus 4.5. Okay, so that's the same as negative 4.5 plus 0.5. Okay, so same signs add, different signs subtract. These are different signs. One's negative and one's positive. So when they're different signs, you subtract them. So I'll do that over here. 4.5 minus 0.5. Bring the decimal straight down. 5 minus 5 is 0. 4 minus nothing is 4. So it's 4.0, which is the same as 4. So same signs add, different signs, they're different signs, subtract, and then you keep the sign of the bigger number. So what's bigger, 0.5 or 4.5? Well, 4.5 is bigger, and it's negative, so the answer is going to be a negative 4, or negative 4.0. So negative 4s equals, that canceled out, so we just have 6. Negative 4s equals 6. So negative 4 times some number equals 6. How are we going to get that s by itself? Okay, well, they're multiplying, they're touching, they're married, so we have to divide both sides. You always divide by the coefficient. So divide by negative 4. Divide by negative 4. Well, negative 4 divided by negative 4 is 1. So it's 1s. We're lazy. We don't write the 1 out front. We just write s. Bring down the equal sign. You guys can divide this if you want, okay? It's going to be negative 1.5, but there's really no need to. Next year, you're going to leave things as improper fractions a lot, or fractions greater than 1. As long as you understand the concept of what it is, then you're good. So this is a fraction right now. It's 6 over negative 4. Okay, so we know it's going to be negative. We can simplify these. What number goes into both 6 and 4? And 2 does. 6 divided by 2 is 3. 4 divided by 2 is 2. So you can just leave the answer as s equals negative 3/2. As long as you know that this is, well, 2 goes into 3 one time with 1 left over. Keep the denominator. As long as you know that that's the same as negative 1.5, you're good. Just leave it like this. This is correct too. So is negative 1.5. But we just leave it like this for simplicity's sake. All right. The second equation. B. So another one with decimals. 2 plus 1.25f. That's an F. Sorry. I read in cursive normally, so it just came out. Equals 10 minus 2.75f. Okay, so pause the video and try this one on your own. And then come back and check if you got it right. All right, so box up the variable so that we can see our like terms. Draw our line. Okay, so we need to combine like terms. So we have our constants that are like terms without the variables, and then our coefficients and variables that are like terms. So let's just do the constants first. So how are we going to combine that 2 and that 10? Well, you could subtract 2 from both sides, or subtract 10. It doesn't matter which one you do. I'm going to subtract 2. And we're subtracting 2 because right now it's a positive 2, and 2 minus 2 equals 0. Subtract 2. Guess they're done taking their shower. So, bring down the 1.25f equals 10 minus 2 is 8. And then bring down the negative 2.75f, or minus 2.75f. Okay? So now what? Well, now we have to combine our variables with the coefficients. So I'm going to move this negative 2.75f to the left side. So that way I have the whole number by itself and the variables on the other side. So you do the opposite because that cancels it out. Right now it was a negative or subtracting, so we're going to add 2.75f to both sides. Well, negative 2.75f plus 2.75f cancels out. That's 0, so we just have 8 left on this side. 1.25f plus 2.75f. 5 plus 5 is 10. Carry the 1. 1, 2, 3. 3 plus 7 is 10. Carry the 1. Bring the decimal straight down. 1, 2, 3, 4. So 4.00f. Guys, if the decimals are 0, that's exactly the same as just 4f equals 8. So 4 times some number equals 8. 4 times what number is 8? 2. And that's how we check it. So divide, because it's being multiplied, by 4. 4 divided by 4 is 1. We're lazy, we just write the f. 8 divided by 4 is 2. And you always can check it. Plug it in. If you plug in or substitute 2 into both f's and solve this, they should equal each other. Both sides should equal each other. Okay, so those are the 2 examples we're going to do with decimals. So next we're going to move on to 2 examples with fractions. Remember, guys, if you're struggling with this and it's just not making sense, contact me. I'm not scary. I'm here for you. So example C. 16 minus 2t equals 3/2 t plus 9. Okay, so always the same first two steps. We box up the variables and draw the line. It's a visual, you don't have to do it, but it just shows you, hey, we have two sides to an equation. Each side is an expression, okay? Equation has the equal sign, expression doesn't. Now, we have like terms on each side. The 16 and the 9, those are our constants, they don't have the variable. The negative 2t, because a minus is the same as a negative, and the 3/2 t. We have to combine like terms. You can start with whichever one you want. You can move them to either side. You should get the right answer as long as you do it correctly. I start with the constants, the numbers, and I keep them positive. So minus 9 cancels out. Minus 9. What I mean by keeping it positive. I know that 16 minus 9 is a positive 7. Where if I subtracted 16 from both sides, I would have gotten a negative 7. I try to minimize how often I have to deal with negative numbers. So 7 minus 2t equals 3/2 t. And that canceled out. So now we have to combine the variables. We have to combine the negative 2t and the 3.5t. We always want our whole numbers, the constants on one side of the equal sign and the variables on the other side. So that's how we're going to determine to move this negative 2t to the right side. So it's on the other side of the equal sign or of the line than the 7. So it's a minus 2t, so we have to add 2t because negative 2t plus 2t equals 0. So that just leaves me with 7. What I do to one side, I have to do to the other side. Should have skipped a line. So 3/2 t plus 2t. Okay, so let's do it over here. 3/2 plus 2. Well, you might know that that's already just going to be, because we have our whole number, this whole number is 0. So you can just add the whole numbers, you get 2. Add the fractions, so 2 and 3/2. Then you can change it to an improper fraction. So you keep the denominator as 2. 2 times 2 is 4, plus 3 is 7. So 7 over 2t. Oops, what happened there? I don't know. 7 over 2t. If you don't like it that way, you could also do it 3 over 2 plus 2. That 2 is over an invisible 1. And then you can get them to have the same denominator. So 2 and 1, we can make them both 2. So this one stays the same, 3 over 2. How do I change 1 to a 2? I times it by 2. So then I have to times the top by 2, the numerator. 3/2 plus 4/2, 3 plus 4 is 7 over 2. Okay, so we have 7 equals 7/2 t. All right, so this fraction and the t, they're touching, they're being multiplied. So we have to divide both sides by the coefficient, by what's in front of the t. Divide by 7 over 2. So anything divided by itself is 1. It cancels out. It just leaves us with t. Divide by 7 over 2. You're more than welcome to use your calculator, but you don't have to. 7 fraction bar 7 over 2. 7 fraction bar. Fraction bar is the same as divide. 7 divided by 7/2. Okay, well, that 7 is the same as 7 over 1. So that's actually 7 over 1 divided by 7 over 2. And we know when we divide fractions, you keep, change, flip. So you keep the first one, 7 over 1, change division to multiplication, and flip that fraction, 2/7. And now you just multiply straight across. 7 times 2 is 14. 1 times 7 is 7. 14 divided by 7 equals 2. Or when you were multiplying, you could have noticed 7 and 7. Well, 7 goes into both of these numbers one time. So then 1 times 2 is 2. 1 times 1 is invisible 1. So t equals 2. You guys do get your calculator. I'm just showing you how to do everything with the skills that you do have. We just don't use them, so then we lose them. All right, so I want to do one more with fractions, because I know fractions are a bit scary sometimes. And if you feel more comfortable changing this to a decimal right off the bat, 1.5, that's fine if you want to do that and just not even deal with the fractions. Perfectly fine. 6d minus 11 over 2 equals 2d minus 13 over 2. Okay, so pause the video and try this one on your own. Okay, so first you have to box up the variable and draw your line, just a visual. Then we combine like terms. So either add 11 over 2 to both sides or add 13 over 2 to both sides. It does not matter. Let's just add the 11 over 2. Just because. So negative 11 over 2 plus 11 over 2 cancels out. Just leaves us with 6d on this side. Bring down that 2d. Negative 13 over 2 plus 11 over 2. So when you're adding or subtracting fractions, they have to have the same denominator, which these two already do. So we know the denominator is going to be 2. So now you're just adding the numerators. What's negative 13 plus 11? Negative 13 plus 11. So same signs add, different signs subtract. These are different signs. One's negative, one's positive. Different signs subtract. 13 minus 11 is 2. What number's bigger, 13 or 11? 13. 13 is negative, so it's negative 2. So negative minus 2 over 2. Well, hey, what's negative 2 over 2 the same as? That's negative 1. So let's rewrite that. 6d equals 2d minus 1. All right, so now let's combine our variables. We want to get the 2d and the 6d together, and we want to get it on the opposite side of the equation, away from the constant. So we're going to subtract 2d because that cancels it out. 2d minus 2d goes away. Subtract 2d. 6d minus 2d is 4d equals, just bring down the negative 1. So that 4 and the d are touching. They're married. They're being multiplied. So how do you undo that? Division. What do we divide both sides by? The coefficient, whatever's in front of the d, because we want to get d by itself. 4 divided by 4 is 1. So d equals, and you can divide negative 1 divided by 4 and get negative 0.25. We just leave it as a fraction though. Negative 1/4. Ta-da! Guys, if you're having questions, reach out to me.